Just want to check the mic here. Somebody could comment section if you can hear me. That would be great. Want to meet everybody? Want to see all the students? Oh, look at that. There they are. Oh, the students. Mwah. The dog will teach class today. Oh, there he is. There's my pup. Oh, the old dog. You want a treat? Oh, a treat? You want a treat? All right, everybody, welcome back to CS 125 Remote. So today our topic is going to be interfaces. We're going to keep talking about interfaces, pick up where we left off last time. We'll go through some examples, and we're actually going to get you started on a couple of the homework problems that you are working on. I apologize, I think I made a mistake with the configuration for today's homework problem. So that is now available on the PrairieLearn website. It is also not due until the end of the break, so you have plenty of time to work on it, and I'm going to hopefully get you started on that toward the end of class today. So in class last time, we introduced the idea of an interface. We talked a little bit more about what an interface is, this place where two different parts of a system come together and interact with each other. It's a place where important communication happens between two different parts of a system, and it's also a place where we need really good structure and very good documentation. And then we talked a little bit about specifically what an interface meant in the Java programming language. So we looked at how to declare an interface. We pointed out that an interface is sort of like an abstract class. We'll revisit that analogy today. And then we talked about some of the reasons why we might use interfaces in our Java programs as opposed to inheritance. And again, we'll come back and we'll revisit some of those arguments today. So, again, an interface is the shared boundary between two parts of a system. And one of the reasons I like to talk about interfaces is because it's such an important idea that comes up all over the place in other parts of computer science, not just in a specific programming language context, but when you design larger systems, when you're working in teams. A lot of what we do as computer scientists, particularly when we're working on things that other people are going to use, and most of the high impact things that you do are things that other people will use, we think about interfaces. We think about how is somebody else going to use my app, for example. So the app you guys are developing has an interface. A good interface makes the app usable and makes people enjoy using it. A poor interface makes the app very confusing and hard to use, right? And I suspect you guys have experience with both of those types of applications. So, recently I've been looking through some new pieces of software that we might use in various places to try to, aid our ability to teach this course online in a virtual setting. And, one of the things that I'm reminded of is that there's some software out there in the world that just has really, really terrible interfaces. Just as a sort of a meta comment about today's class, I think I got distracted by showing you guys the dog. I disabled the comment section on the YouTube live stream, but I am going to keep my eye on the topic on the forum. So I posted an announcement. You guys should be able to reply to that if you have questions. I'll peek at that from time to time. I'm obviously not going to be looking at it constantly, but if you have a question or there's something you want me to talk about, feel free to drop a note on that post. The comment section was a little difficult for me to use, just in the sense that there was a lot of stuff flying by. I think there were some questions embedded in that stream, but they were very hard to see and they really quickly vanished off the screen. So hopefully this will work better. Okay, so again, one of the reasons we talk about interfaces is this, as a computer scientist, as a software developer in particular, you spend a lot of time thinking about interfaces, figuring out how to use the interface that someone else is providing for their code, and figuring out how to design an interface for your own tool so that other people can use it. We talked all about the different types of interfaces that we see within a single computer system, right? So interfaces between two different pieces of software, interfaces between software and hardware, interfaces between the human user and either the software or the hardware. And these interfaces are all really interesting places, right? They're places where a lot of research gets done, and they're places where you can really make a difference when you design good applications for other people to use, right? Again, not to harp on this, but as a software developer and as a computer scientist, when you build things for other people to use, one of the biggest differentiators between your tool and other similar tools is the interface. That's how people are going to pick, I really like this library that Jenna created because it's really intuitive and it's really easy to understand how to use it. And that's partly a function of the interface itself. It's also partly a function of interface documentation. So we also last time introduced a very specific way that Java defines an interface. So Java, the programming language, has a very specific idea of what an interface is. And essentially, Java's idea of an interface is it's a set of methods that your object can choose to implement. So here's an interface declaration in the Java programming language. This might remind you a little bit of a class, right? I've got my public keyword. I've got an interface keyword instead of a class. So that's the difference. That's what makes this an interface instead of a class. I have a name that shares the naming conventions for classes. That is, it's capitalized. And then I open up a block. And inside this block, what I typically will have is a series of things that look like method declarations, but they don't have a body. So this looks very much like how I would declare a method named add, except that except that it has no body, right? So I have a method named add, it returns an int, it takes two parameters, first and second, but instead of continuing on with the body of this method, which is what I would normally do, I would open up a block, and then I would implement add, doing whatever I needed to do with the parameters to kind of match what the function declaration said that this method was supposed to do. I just have a semicolon, right? And so what I'm saying here is that if you choose to implement the add interface, you must implement a function with this signature. I don't tell you how to do it. If I knew how to do it, I'd put it right in the interface declaration, or you wouldn't need an interface, right? But what I'm saying is that your function your class can now choose to support this interface by implementing a method with this signature. And how you implement that method is up to you. And again, we'll come back and we'll talk about, exactly why, why this is the case, right? So this particular method, you might think, well, there's only one way to implement add, and that's true. But when we talk about the comparable interface, which is one of our favorite examples to talk about interfaces, we'll see that different classes implement comparable differently, even if compare to has a very specific way in which it's supposed to behave. Okay, so And again, I just said all these things. I can declare variables in my interfaces, but those variables end up being public static final. So we're really going to focus on interfaces declaring methods, right? That's where they're most interesting. So an interface on its own is really just a contract, right? This establishes an expectation between two parts of my system about how something's going to behave. In order for an interface to be useful, two things have to be the case. First of all, somebody has to implement it. So some class has to choose that they are going to implement the contract that is defined in that interface. And the way that you do that is when you declare your class, you add this stanza to the class declaration and you say, I'm going to implement this interface. When you do that, the Java compiler will then require you to provide an implementation matching the signature for this method. So I need to provide a method. It has to have the same name, it has to have the same return type, and it has to have the same types of parameters. I can change the names of the parameters, but it has to have the same types in the same parameter order. And what the method does is up to me. Okay, so the interface doesn't say anything about how I'm supposed to implement add. It probably has some documentation that will talk about exactly how add should work. So it sets up an expectation about the semantics of this function, but it doesn't provide the implementation. When I implement the interface, I'm expected to provide an implementation for all the methods that are specified in that interface. Okay. So let's go, we can look at a little example here. So here I have my interface declaration, which is up at the top. I've declared a public class, and right now that class does not declare that it implements the interface, and it also doesn't implement the interface methods. Okay. So if I run this, I'm going to get an error from the Java compiler that says that I can't cast adder to an add. I can't treat an instance of adder as a reference to something that implements the add interface because it doesn't implement the add interface. And so the first thing I need to do to fix that is I need to first declare, when I declare my class, that I'm going to implement this interface. That's the first step. Now when I run the code, I get a different error, which says that adder does not override this abstract method. So essentially, I have not provided an implementation for int add. So I need to implement this method in some way. And again, I just want to make sure that we're on the same page here. Interfaces aren't magic. There's a way for the Java compiler to know that you've implemented add correctly, right? So again, what I really need here is I need some documentation. So let me put some Java document here that says return the sum of the two arguments. And then down here, if I was doing this properly, I would say int add, int first, int second, and then I return first plus second. And NAS has declared that it's going to implement this interface, and it's also provided an implementation for all of the methods included in this interface. This interface only defines one method. That's fine. Interfaces don't have to define more than one method. In fact, there's a lot of interfaces that only define one method. They can define multiple methods, but to implement the interface completely, I have to implement all the methods that it enumerates. Okay, so this seems to work how I want, but just to be clear, there's nothing stopping me from doing this incorrectly. So if I was a bad programmer and I didn't read the documentation, I might implement add incorrectly. All an interface ensures is that the user of my class knows that they can call a method named add that takes two integer arguments, and they can expect an integer in return. That's all. That's all I guarantee. I don't guarantee that you did the right thing here, right? And in a few slides, we'll look at some examples of how to implement an interface that allows two objects to be compared with each other. And there we can actually make some mistakes and see how they play out, right? All right. One of the things that we just looked at is that, remember we talked about object casting. We said that Java will automatically cast an instance of a class, an object, to any one of its parent classes. And this also applies in a different way to interfaces. So when I have an instance of an object that implements a particular interface, I can store a reference to it in a reference variable that is of the type of the interface type. Okay? I don't think I said that very clearly, so let's look at an example here. So on the right side of this expression, I say new adder. So I'm creating a new instance of the adder class. Adder has declared that it implements add, and it also implements the required function. So it provides an implementation for add. And in this case, it does the right thing. On the left side, I'm declaring a reference variable. Good chance for us to practice this. I'm creating a reference variable of the interface type. So this is a reference variable that can store a reference to anything that implements the add interface. So what I'm doing here is I'm casting my adder object into an add reference, right? So my lowercase add variable can store anything that implements the add interface. Because adder implements the add interface, I can store a reference to it in the add variable. Now, what's interesting about this is once I do that, I can call the add method, because anything that I can refer to as something that implements the add interface is guaranteed to have this method. It's a method called add. It takes two integer parameters and returns an integer. But I've lost the ability to call this multiply method, right? The multiply method is part of the adder class, but because I've cast my adder to be an add interface type, I've lost the ability to call methods that adder implements that are not part of the add interface. So yeah, hopefully that answers the question that somebody just asked on the forum. All right, so let's sort of see how this works in practice. I'm sorry with the bullets. For some reason on the live stream, I'm just bad with the bullets. Maybe it's I don't have my little clicker or something. I don't know, but I'm working on this. This is new for everybody. All right, so again, just to look at this in the playground, let's look at the difference between these two examples. So as always, when I create adder, I can just store it in a reference variable that stores references to things, to adders, right? And in this case, both of these examples work fine, because what I have is a reference variable that stores a reference to anything that is an adder or descends from adder. And so in this case, I can call both the add and the multiply methods. But if I change this to an add reference, now I can't, because Java is going to limit me to only being able to call the methods that every class that implements the add interface is guaranteed to have. So again, let's do another example. This is similar to something we did last time, but I think it's good review. We'll create another adder. We'll implement add. I can borrow and I need to change the name of keyword implements. I can borrow the code from that example up here. Okay, let's make sure this. Okay, so that's not going to compile because I'm trying to do this. So now what I want to show you is that because I have an add reference, I can reset that to refer to another adder. Nope. You would think I would be better at typing on the fancy keyboards that I have at home, but apparently not. All right, so now you'll see I can do these both, and if I wanted them to behave differently for some reason, I could do that too. So again, because when I do reference casting, when I have an interface type on my reference variable, that reference variable can store a reference to anything that implements the interface. So here I start off by setting it to refer to an instance of adder, which implements add, and that implements add properly by returning the two arguments added together. But I can also set it to refer to an instance of another adder, which also implements add. And now maybe it's more clear that the reason that I can't call multiply on this is because not every thing that implements the add interface is guaranteed to have a multiply method. In this case, adder has a multiply method and another adder does not. All right, let me go check the questions thread. Just to see, sorry, I got sucked into something else here. It looked like there were a couple of questions. I think one of them I might have addressed. Yeah, so there's one question about what are the benefits of implementing an interface. We'll get there, right? Give me a few minutes on that one, and we'll come back, because I think right now these toy examples use this idea of implementing an add function, and there's only one right way to do that. In a few minutes, we'll look at cases where I'm implementing a function where the way to implement it depends on the class that's implementing it. And so there's a lot of benefit in having each class be able to implement it differently. Okay, so hopefully that'll clear things up, right? So last time we pointed out that I can draw parallels between inheritance and interfaces, and basically a combination of inheritance and overloading, right? So an interface behaves a little bit like a parent class. Implement, you can substitute extends, and then providing your own implementation is sort of like overriding a method that was provided by the parent. And we pointed out that we can make this even more similar by using both abstract classes and abstract methods, right? So if I have an abstract class, that class cannot be instantiated. That's similar to an interface. So just to be clear, I can't create an instance of an interface. So if I try to do something like this, it's not going to let me. It gives me this kind of weird error, but essentially if I have something that's an interface, I can't put it to the right of new. I can't create an instance of that class, right? But if I use abstract classes, I can't do it either, right? So if I have an abstract class, I can't create an instance of that class either. And so going back here, let's actually go ahead and just modify this to accomplish essentially the same thing using abstract classes, inheritance, and overriding, right? So now let's make this an abstract class. And now the trick here is that on an abstract class, I can't normally provide an empty method. But if I make this public abstract int add, then what you're going to see is I'm going to get very, very similar behavior. Okay. Now I have to change implements to extends, and right, and I have the same problem down here. Let me comment this out. This problem is not going to go away. Boom. Okay. So again, I made this small change, right? I changed my add interface to an abstract class. I changed implements to extends, and I made the method that was declared in my interface abstract, and I can kind of do the same thing, right? So the question is, why do we use interfaces? And the real reason is that interfaces allow classes to implement behavior that may not correspond to their position within the inheritance tree, right? So here, the idea is that if anything wants to implement add, it has to extend this add abstract class, right? But what if I have a class that's often another part of the Java inheritance tree that still wants to implement add? It wouldn't be able to do that. I'd have to reorganize the whole tree. And this is the main reason that we use interfaces. Interfaces also solve this problem that we have in Java concerning multiple inheritance. So Java does not allow classes to declare that they extend more than one parent class. So I can't mix behaviors from different parent classes together. I can do this with interfaces. So a class can declare that it implements as many interfaces as it wants, right? To implement two interfaces, I have to implement all the methods that are provided by both of those interfaces. And here's, this is an example from last time showing how to do that. In this case, I have two interfaces, add and subtract. Each one just has one method. And I have this mathy class that implements both by providing a method to satisfy the add interface, providing a subtract method that satisfies the subtract interface. And now I can use mathy as an adder. I can also use mathy, let's see here, subtract is equal to new mathy. I can create another mathy instance that does subtraction. Right, so I can essentially use this as either one of the, I need to actually spell things properly, subtract. There we go. And I need to, what did I do here? Oh, sorry, I need to use subtract, not add. All right, so now I have a subtract instance and an add instance, and I can use either one of them. I can use this. I can use an instance of this class as something that implements either one of these interfaces, right? So the real reason, and so again, this concept of a math interface is a little bit silly because there's only one right way to implement add and subtract. And so maybe in the future we should go back and fix this so it's not so trivial, right? Because I think may not exactly make the point that we're trying to make in the best way. But what we really normally do is we use an interface to establish a contract between two parts of the system that establishes an expectation about something a class is going to do that is sort of abstract, right? And the class is allowed to provide its own implementation in a way that's appropriate to it, right? And so let's now shift this toward a discussion of something that's far more useful, right? Which is this idea of being able to put two objects in order. So let's imagine that I have two instances of a class, and I want to do something very simple, okay? This is a very simple primitive. What's awesome about it is how useful it turns out to be, okay? So I've got two instances of any class, and I just want to answer a simple question, right? Which one of them goes first and which one goes second, okay? So imagine I want to sort them. Then I need to essentially, when I sort, and we'll talk about sorting algorithms later in the class, I need to make lots of little decisions about how to compare two items to each other, right? I have to do that over and over again. Let's say I want to tell you which one is bigger than the other. Well, that boils down to taking two instances of the class and figuring out which one goes first, is bigger, which one goes second, smaller, right? Maximum, minimum, there's all sorts of these things that I can do, right? And so now what we have is a better example of an interface, because what you can do in Java, and this is an actual Java interface, you can implement this in your own classes. If you implement comparable, what you have to do, and let me go back and show this again, is you have to implement a single function called compare2. That function takes an object reference as an argument, and it returns an integer that indicates whether or not, basically indicates the order in which these two objects should be put. So I take one instance of your object, I call compare2 on it, and I compare it with something else. And your class is supposed to say it's a negative integer, 0, or positive integer, depending on which one goes first, okay? If it's 0, the two of them are the same, right? They basically belong in the same place. So if you ask me which one is bigger, you would say they're equal. If it's negative, then one of them goes first. If it's positive, the other goes first. So all this value does, okay, there are basically three possible things that you can return. You can return a negative number, a positive number, or 0. And what this does is it makes this decision for some other piece of code that's using your class. So now any other piece of code that needs to put two instances of your class in order can do that, right? Now, I talked about this a little bit last time, but I love talking about it, so I'm going to talk about it again. Why is this so useful? So it turns out that the ability to compare two classes allows other people to build all sorts of useful pieces of software and libraries and things that you might want to use. So for example, sorting. We're going to talk about sorting later in the class and how important sorting is as a primitive that we use to build all sorts of really complex pieces of logic, right? So there are still big international competitions to build more efficient sorting systems that are held every year. And that's because this is such an important problem that acts as a building block for so many other algorithms, okay? But if you tell me, all you have to do, you don't have to write a sorting algorithm, right? There's lots of sorting algorithms, and some of them are really complicated. But you don't have to do that, okay? You can allow all those algorithms to work on your class if all you do is provide the answer to a very simple question, which is, given two instances of your class, how do you compare them to each other? Again, we're going to do this in a minute. I can find the maximum value over an array if all you do is tell me how to compare two instances of your class to one to another. And you can also organize those classes into a variety of different data structures, including something called a binary tree that enables very efficient search. So sorting is one algorithm that lots of other algorithms are built around, and search is another algorithm that a lot of other algorithms are built around. I can do very efficient search over large numbers of instances of your class if you tell me how to put them in order, okay? Now, you know, this, and so we talked about how interfaces are a place where two things come together and meet, and where there's communication and coordination required at that point. But the other cool thing about interfaces is that on both sides of that meeting place, there's not coordination or communication required. So I can build two completely independent systems, right? So for example, I can build a sorting algorithm. I can make my sorting algorithm really complicated, and I can spend years perfecting it and writing that code. And I don't have to know anything about your class. Okay, you can build a class that does all sorts of other cool stuff that is designed to support, the logic behind your highly impactful application, right? So you do that on your own. The two of us never have to meet, never have to talk to each other. But if we can agree on how to express a comparison between two instances of a class in Java, which is what the comparable interface does, now my sorting algorithm that I spent all this time working on can be used on your class, which you spent all this time working on. And the two of us never have to meet, we never have to talk to each other, we never have to know anything about each other. You never have to know that I'm using your library to sort things. I never have to know that your cool app is using my library to sort instances. This all happens completely independently, right? And it's because we've made one important decision together as a community, which is what's the interface that we're going to use to express how to compare two objects together, right? And so again, this is why so much of modern software development works, right? So there are so many people out there in the world right now writing software, and that's one of the most exciting things about learning computer science is you're entering into this really exciting, huge community of people out there who are all solving problems together. And a lot of times the problems that other people solve end up helping you solve your problems, right? But one of the reasons that we can work so independently and we can all make forward progress is because we agree on certain things, right? Certain small things that we agree on. We'll talk about more of them later in the semester, that everybody kind of buys into, and then this allows this independence, right? While still allowing two things to work together perfectly, right? Okay, so let's look at one of the homework problems, and we'll look at that recent homework problems that looked at compare to. Okay, this is a review of a homework problem you did a couple days ago. So what we're going to do is we're going to implement compare to on a class called string length. Okay, now string length stores a string internally, but strings have their own comparable method. So when I compare two strings in Java, we'll see this in a few minutes, what I get is a lexicographic comparison. So this puts this in sort of dictionary order, right? But my string length class, what I actually want to do is I want to order it by the length of the string, right? So if you sort strings using the default string compared to, what you get is dictionary order. What I want is a sorting algorithm that allows me to sort them from the smallest string to the largest string, just by the number of characters, okay? So this is kind of the rest of the setup for this problem. This is the description of our compare to interface. And again, in this case, what we've done is we've actually inverted the typical comparable interface, the official one that we will use in the future. But the result here is really just a convention. What's negative, what's positive is sort of arbitrary. All right, so here's our comparable interface, right? To implement comparable, we have to provide a single function called compare to. I've created my string length class, and let's see here. String length wraps a string and should provide a constructor that takes a string as a single parameter, okay? So first thing let's do is let's write our constructor, string length. That takes a string as a parameter, and I'll just call this set string to follow our usual convention. We'll create a private instance variable called string, and we'll have our constructor set string equal to the passed argument. And now let's just make sure that this works. So I'm going to say string length is equal to new string length, and I'll pass it a string. Okay. All right, that seems to compile and run, so we're good. All right. So now what we need to do is we actually need to implement this comparable interface. So the first thing we're going to do is we're going to implement, we're going to declare that we implement comparable. I need to use implements, not implement. And now what I have to do is I have to provide this other method called compare to. And this needs to be a public method that returns an int. Now, let's go back and now look at the instructions. So we're going to look later in the class about how to handle the case where you're passed something that's not a string length. But our instructions say that if the passed object is null or not an instance of string length, you should just return -1. okay? And this is kind of similar to what we saw when we did equals, right? Which is the first thing we need to do is handle the case where either other is null or other is not a string length object. It's some other type of object. So we'll say if other is equal to null or other, say not other instance of string length, return -1. Just to satisfy this, I'll return 0 there, just make sure it compiles. Now let's try this to see if things are working. Let's try comparing it to, I don't know, let's try comparing it to null. We'll print the result of that comparison. Okay, that looks correct. And now let's just try comparing it with something that's an object but not a string length. That also works, okay. We could try comparing it with a string. Strings are not string length objects. That should also return -1. Okay, good. So now we've handled those cases. Now we need to finish the job. So at this point, if we go back to our instructions, let's go back and look at the previous, oops. Sorry about that. Let's go back and look at the previous slide. It says that, and we need to use the length of the string instance variable, right? So what we're going to do is we're going to say 0 if they're equal, -1 is other is less, so other is shorter. So go forward. Now we say, well, the first thing we need to do is we actually need to downcast other to a string length instance. So because we did this checkup here, we know that we would have already returned if other is not a string length or something that can be cast to string length. So now we'll do string length, other string length, and we'll just do this explicit downcast of the other reference since we know this is safe now. And now we can write our if statement. So now we say if, and you can use this here sometimes because it's a little bit more clear. I'm not going to do that. So I'm going to say if string.length, there are 3 cases, is less than other.length. That's one that we need to handle. Else if string.length is greater than, oh, it's a function, it's greater than other dot, oh, sorry, it's other dot string.length. Other dot string. So now we know that other is a string length instance. Is because this is code that's running on the string length class, we can access private methods of the other class. Okay, so if it's greater, else this is the equal case. So we know what to do if they're equal. We return 0. And now you just have to look at the documentation carefully. If other is less than the specified object, so that's this one, right? Here we're going to turn -1. Otherwise here we'll return 1. So if other is greater, we return 1. That's correct according to our definition of comparable. It's -1 if other is less. That's right here. And then 0 if they're the same. So we're only going to fall through here if they're the same. Oh, I need to use other string length dot string. Sorry. Use my downcasted reference. That seems to, okay, so now let's try this. All right, so I'm going to create 2 string length instances, and I'm going to, now I'll call this first and second, just to keep things clear. And I'll make them so they're different lengths. And now I'm going to call first.compare to second. See what happens. Oh, I've typoed something here. It's right over here. I've still typoed it. Length. There we go. Okay, so in this case, I'm getting a negative result. I've got 2 string lengths, and so I want to make sure that that's correct. So I go back here, and it says if other is less than the specified object. So in this case, other is second. The specified object is first. First has a length of 4. Other has a length of 2, so that's correct. Now let's invert this comparison. So now it looks like this is correct. So anytime I have a compare to, if it returns -1 and I invert it, it should return 1. Or if it returns a negative number and I invert it, it should return a positive number. And now let's make sure that it handles the case properly where the two of them are the same length, 0, okay? And also, whenever I implement compare to properly, if I call an object and I compare it to itself, I should get 0 because those objects are actually equal, right? Okay, so now what we've done, and let's just step back and look at this, right? We have now created a class that can be sorted, right? We've created a class where I can find the maximum. So if you give me a whole array of string length objects, I can find the maximum over that entire array, right? But the cool thing is I can use the same code that finds the maximum over that array to find the maximum over an array of strings that use lexicographic comparisons, or an array of numbers that have an inherent, ordering, right? We'll see that in a second. Okay. I would normally ask for questions here. I think what I'll do is just sort of barrel forward, and then I'll take some questions at the end, right? So I just pointed out all this stuff. And we will actually come back and use comparable in the future when we write data structures and algorithms, both when we do things like work with binary trees and when we talk about sorting and searching. Okay, but let's stop and let me ask a different question here, right? Which is that we know that equality testing is part of one of those methods that's provided by capital O object. And so every single Java object has to provide that method. Right? You can override the default one that you inherit from capital object or from one of your parents, but you have to provide it. But why is it a choice to implement comparable? So essentially what this means is that in Java, every object has an equality method. Every object has a way to say, am I equal to another object, okay? That returns true or false. But not every object has a sorting method. So equality is a binary comparison, returns true or false. Either things are equal or they're not. Comparable is a ternary method. It says the two things might be equal, but one might go in front of the other, or the other might go in front of the first one, right? So essentially, comparable has 3 results, equality has 2 results. So the question is, given how useful comparable is, why doesn't every Java object have to provide it, right? And essentially what Java decided is that it's natural for every object to have a notion of equality, but not every class supports meaningful comparison, right? And I might ask you to think about this kind of offline, and maybe we can discuss this on the forum later, but what are some examples of classes that don't have a meaningful notion of comparison? Because there are some things that I model in the world that I don't really have a way to put in order, right? I could put them in order, but it's sort of arbitrary, right? Let's say those dog classes that we were looking at before, right? Is there like a natural, widely agreed upon way to put dogs in order? I mean, maybe like these kennel clubs have something that they use for dog shows. Maybe you put them in order by height or by weight. I don't know. It's sort of arbitrary. I mean, you can find ways to do it, right? If somebody said, okay, take all these dogs and put them in order, right? You could do it, but if you did it and a friend did it and another friend did it, guys might come up with 3 different ways of doing it that were all valid, right? One might put them in order by color, right? But they're different, right? So there's no widely agreed upon way of putting dogs in order. Whereas, like we said before, with words, in most languages, I would suspect many to not all languages, there's a widely agreed upon way of putting words in order because you want to be able to do things like have a dictionary, right? Or to have a dictionary, I have to put things in order, right? If I had a dictionary that just contained random words all over the place, it's not very useful, right? So some things that we model with some of our classes, some categories of things in the world have a natural ordering, some don't, right? And so by having comparable be an interface, it allows the classes that can provide comparable in a meaningful, natural way to opt into this behavior, while classes that don't have a natural way of being comparable don't have to opt into that behavior, right? Okay. So now we're gonna, is this homework 42? Yeah, so now, this is the maximum that we were gonna do last time, but I think instead, let's just look at minimum, right? Which is your homework problem that opens up today, right? This is sort of my way of luring people into watching today's class because there is a little bit of some work that we're about to do together on a homework problem that's due after break, okay? So what we did, and I also want to draw a distinction here between providing the interface and using the interface, okay? So here what we did is we provided the comparable interface. We took a class called string length and we implemented comparable, which allows instances of string length to be put in order. This is the provider of the interface. It's the class that implements comparable. Now what we're going to do is we're going to act as the user of the interface. So the user of the interface does not have to implement comparable. The user of the interface uses objects that are comparable and does something useful with them. So in this case, what we're going to do is we're going to take an array of any object that can be comparable, and we're going to find the minimum value. All right? And this is a reminder about how compare-to works. So here is the method signature that we need to implement. This is, I just put this inside a class, but it's a static method, right? So there's no state that we're going to associate with this class. It's a static method. It returns a reference to something that's comparable, and it takes as an argument an array of things that are comparable. And what you need to do is you need to return the minimum value from that array. Now, this is a common source of confusion, so I want to emphasize it here. This class does not have to implement comparable, right? So we are not going to implement comparable here, okay? This class does not need to implement comparable because this class is using the comparable interface. It's not providing the comparable interface. This class is taking advantage of a feature that every object in Java that can be comparable already provides. And that feature is they have this method called compare-to, right, that returns an integer. So let's look at how to do this, okay? So we had, in the past, we've done min and max over arrays of things like integers. And the algorithm is exactly the same, right? So maybe for a minute, let's just pretend that, let's just revisit how we would do this. Let me write actually a different function that takes an array of ints and returns the minimum. And we'll kind of use this as practice, right? So how would we do this in the past? So we would say if values is equal to null or values.length is equal to 0, we would return some value in 0, right? There's no minimum of a null array and there's no minimum of an empty array. So, you know, there's no way to address this problem. We'll talk about this later when we talk about exceptions, but for now we'll just return 0 in this case. Then we'll handle the case if values.length is equal to 1, return value 0. This is the kind of corner case where the array only has only one value in it, so that is the minimum. Otherwise, what we do is we say current minimum is equal to values 0. So basically, we initialize the current minimum to be the first element in the array, and then we go through, we say int I is equal to 0. This is good practice at our imperative programming that we'll get back to after the break. I is less than values.length, I plus plus. Sorry, we're going to start at 1 because we're skipping the first element. And now we say if values I is less than current minimum. So if the value in the array at this position is less than what we think is the minimum, we set the current minimum equal to that value. And we go on. And then when we're done, we return current minimum. And so let's, first of all, compile this. It's mad at me about some check style mistake. Oh, it's over here. I'll fix that. But let's actually run this on an array of integers and just make sure that it does the right thing. So we'll do, these don't work yet because they're using the second version of comparable. Println minimum min new int, and let's give it 1, 2, 5. I need to actually spell print properly, and it's still angry. Check style, probably fix that at some point. Okay, so that works. Let's put a smaller value here at the end of the array. That also works. Let's put the smallest value in the middle of the array somewhere. That also works. Okay. So this is our algorithm, right? We know how to do this. We have just never done it in a general way before. We did it in a specific way that would only work for an array of integers. So how do we generalize this approach? So some of this we can use directly, right? So this stuff is exactly the same. And in fact, I'm just going to cut and paste it. In fact, it's all the same down to here. And if, you know what? This is so similar, I'm just going to take the whole thing. All right, so a lot of this is identical. There's only one small change that we're going to have to make. So this still works fine if the array is null or the array doesn't have any entries. This also still works fine if the array only has one value. You know, if we were together, I would ask people to kind of point out the place where we're going to get into trouble, but in this case, we'll just let the compiler do it for us. So we need to change the type of our return value, right? So what we're returning is a comparable. So that's the first problem. And then what it's going to complain about is this, right? The problem is the less than operator that I can use with two integer operands cannot be applied to two comparables, okay? But it turns out that we know exactly how to replace it, because if I have two comparable objects, then I know that I can compare one of them to the other using this compare to method. Now, one of the things to note here is that there won't be any null references inside the array. So we don't have to be careful about what we call compare to on, okay? So all we need to do is we need to basically say if values I.compare to current minimum, and then there's some value that's going to do the right thing here, right? So let's try less than 0, right? And we'll see if this works properly. It might be greater than 0. This is one of those places where I would just say mess around. So the question is this working properly? And it looks like it is, right? 5 is lexicographically the smallest string in this array because F comes before T and O in the alphabet. 1 is the smallest value in this array of integers. And I can run this again, and I can use -1, and it seems to work. Okay? So we're out of time today. I've done the homework problem for you, so hopefully you appreciate that. But I just want to emphasize this because I don't want this to get lost in translation, right? What we've done is we've built a completely general purpose comparison method a general purpose min method that can be run on any array of any Java object that implements comparable. So as soon as you implement comparable, your array of objects can be passed to this function. And so to drive that home, let's go back and let's get our string length class. Let's grab that, and we'll go ahead and just drop it in here. I'll put it above the minimum class. So now I have a string length class, and keep in mind I need to fix this because I did this backwards before, okay? So now let's pass an array of string length objects. So string length now is the provider, one of the providers of the interface. The minimum class should work on anything that's comparable, and that includes string length. I need to make these string length objects. So I'll new string length 1, and let's just do 2 because I'm running out of time. 2, and then I'll just put this on a new line, and hopefully checkstyle isn't too angry. Oh, it is angry. It wants a little bit more white space here. I can do that. Okay. I need a print method here. Let's add a public string to string, and let's just return the string method, or the string component of this. Cool. So these are actually the same length, but let's make a longer one, right? There you go, right? So minimum is now returning the shorter string from this array. If I make this longer, then it's going to return 3, right? And so I have created in this code one of the first pieces of code we've written together this semester that is completely general, right? It'll work for anything that implements comparable, right? Any object that chooses to provide the comparable interface can be used by this minimum method that we wrote together. Okay, that's great. I don't have much to say today. I hope you guys have a fantastic break. Please take care of yourselves as you go home or don't go home, or go somewhere or don't go somewhere. There's a lot of uncertainty out there in the world right now, and I'm sure you guys are all under a fair amount of stress. So, please exercise good self-care. Be good to yourselves, be good to the people around you. exercise the necessary steps in order to stay healthy. We will be back together after break in some way or another. We're going to be working hard the entire break to figure out some of the best ways that we can provide you with the help you need for the rest of the semester and ensure that you learn the materials that you can go on to a glorious future in computer science. Anyway, I'm looking forward to a little bit of a break, but again, me and the course staff will be hard at work over spring break, working to figure out how to complete the course together. If you have any questions or concerns, please feel free to post on the forum, contact me, directly or whatever. But I look forward to seeing you guys all in a couple of weeks. I hope you have a restful break in some form or another, and I'll see you a week and a half from today.